Hello everyone, this is Harrison Galway, and today I will be teaching you how to draw Lewis structures for molecular compounds, which are the same as covalent compounds. So I've written out here the steps that I like to use to do this. I'll walk you through them and then we'll do a couple examples. So, the first thing you need to do is you're going to take whatever chemical formula you've been given, and you're going to put the least electronegative atom in the center, and then just draw single bonds to the other atoms. Now, the way you'll know which atom is the least electronegative is you can use this mnemonic device, Fonkelbrich. This lists the most electronegative elements in order from most electronegative to least electronegative. So, most electronegative is fluorine, followed by oxygen, then nitrogen, chlorine, bromine, iodine, sulfur, carbon, hydrogen. And the rest of the elements in the periodic table are even less electronegative than this, but most of your Lewis structures will involve these elements. So you're going to take whichever one is least electronegative and put it in the center, and then just draw single bonds to the other atoms. However, hydrogen, though it is the least electronegative of this list, will never be in the center because it can only have 2 electrons surrounding it. The next thing you'll do is you'll take that structure that you drew and add lone pairs to all of the atoms until they all have an octet or 8 total electrons surrounding them. Again, hydrogen is an exception. It only requires 2 electrons. Now, when you're counting how many electrons you have around an atom, of course, all of the lone pairs will count as 2, but bonds also count as 2 electrons. So once you've done that, you'll then stop and calculate what I like to call your budget of electrons. And the way you do that is you add up all of the valence electrons those atoms generally have by using the periodic table. So, I'll show you what I mean by that soon, but in general, you'll just add up all of the valence electrons. However, if you're doing a Lewis structure for an ion or a charged molecule, you'll need to sort of change that total depending on the charge. For instance, if the molecule you're doing has a charge of -2, you'll need to add 2 additional electrons to the total that you got. You'll then compare your budget that you got to the number of electrons you actually used in your structure. Now, if you've used too many electrons, if you've overspent, the way you can consolidate is you'll erase lone pairs on 2 adjacent atoms in the structure and add an additional bond between them. By doing that, you'll reduce the number of electrons in your structure and hopefully get closer to your budget. On the other hand, if you've used too few electrons in your structure compared to your budget, you'll add lone pairs to the central atom until you have used the same number of electrons in your structure that you calculated for your budget. A couple little caveats here. Firstly, when you have elements in the 3rd row or beyond of the periodic table, those elements can have, or atoms of those elements can have more than 8 electrons surrounding them. We call that an expanded octet. And, boron here is a special case that you should, it's worth remembering that boron doesn't necessarily need to have a full octet. In fact, you generally see it with an incomplete octet or less than 8 surrounding electrons. So, with that, here are a few examples. So the first one I have here is NH3 or ammonia. So what we do is we first decide what the central atom is going to be. Now, since hydrogen can't be the central atom, that really just leaves nitrogen. And what we do next is we just connect all of the other atoms to the central atom with single bonds. Then we make sure everything has a full octet by adding lone pairs. So nitrogen, well, remember, bonds count for 2 electrons. So nitrogen has 2, 4, 6 surrounding it. So we'll need to add a lone pair to get to 8. Meanwhile, the hydrogen atoms don't want 8 electrons. They only want 2. So this hydrogen has 2, this hydrogen has 2, this hydrogen has 2, so they're all satisfied. So what we'll now do is we'll figure out what our budget is for this structure. So to find the budget, you're going to take these atoms here and you're going to use the periodic table to see how many valence electrons they generally have. So nitrogen, if we look down here, here's where we find nitrogen. And the number of valence electrons is easy to determine. You just count from the left. 1, 2, 3, 4, 5. So nitrogen has 5 valence electrons. So we have the 5 valence electrons from nitrogen. And there's only one nitrogen atom. And then we have 3 hydrogen atoms. And hydrogen has just 1 valence electron. So we have to add 3 times 1 to our budget, and that gives us a budget of 8 electrons. So that's what I mean by budget. It's just what you get when you add up the valence electrons for all the atoms in the formula. So now we take a look at our structure and we see how many electrons we used and compare that to our budget. So remember, the bonds count for 2 electrons, so 2, 4, 6, and then we have a lone pair here making 8. And our structure uses just the right number of electrons to match our budget, so we are done. And indeed, this is the Lewis structure for ammonia. On to the next example. Here we have CH2O. So the first step is to just figure out which of these atoms should be the central atom. And remember, we choose the least electronegative atom, with the exception of hydrogen, to be in the center. And that mnemonic device I mentioned was Fonkel-Brish. So carbon is less electronegative than oxygen, and it can't be hydrogen, so we'll put the carbon in the center. And we'll connect the carbon with single bonds to the other 3 atoms in the structure. We have 2 hydrogens and 1 oxygen. We'll then put lone pairs around everything in order to give it all of the atoms an octet. So oxygen is going to need 3 lone pairs to have 8 total electrons around it. Carbon already has 2, 4, 6, so it needs 1 lone pair to have an octet. And hydrogen is the exception. It doesn't need an octet. It only needs 2 electrons, which it already has. So now we'll calculate our budget. So let's see what the budget will be. Budget. So for the budget, we just add up the total valence electrons. So carbon, we have 1 carbon, and carbon has 1, 2, 3, 4 valence electrons. So 4, we only have 1 carbon, plus we have 2 hydrogens, and if you remember before, hydrogen has just 1 valence electron, so 2 times 1. And the last atom is oxygen, so let's check the periodic table. Oxygen has 1, 2, 3, 4, 5, 6 valence electrons. So plus 6, and we just have 1 oxygen here. So our total is 12. And let's check and count and see how many we used in our structure. Let's see, we have 1, 2. The bonds represent 2 electrons. 2, 4, 6, 8, 10, 12, 14. So we've overspent. And so in order to save on our electrons and cut down on the number, what we can do is we can erase lone pairs on 2 adjacent atoms. So I'm going to take the lone pair on this oxygen, one of the lone pairs on the oxygen, and the lone pair on the carbon. I'm going to erase them both, and in their place, I'm going to add an additional bond between the 2 atoms. Now by doing that, I haven't messed up the octets. Notice carbon still has a total of 8 electrons, 2, 4, 6, 8 total electrons. Oxygen still has 8, 2, 4, 6, 8. But by removing 4 electrons and adding 2 electrons, I've cut down in the total number. So now let's check our structure once more to see if we match the budget now. 2, 4, 6, 8, 10, 12. Perfect. So we match the budget and we're done. This is the correct Lewis structure for this compound CH2O. Moving on. Next we have N2. Technically not a compound. A compound requires two or more different elements. This is technically just a molecule, molecular nitrogen. But the steps for doing the Lewis structure are the same. We only have two atoms here, so there isn't really a central atom. We'll just bond the two atoms together, and we'll give them octets, as we generally do. Okay, great. So that's how we start. Now we're going to find, yet again, our budget. So to find the budget, let's just find nitrogen in the periodic table. And nitrogen's here. Let's count the number of valence electrons. 1, 2, 3, 4, 5. So 5 valence electrons for nitrogen. And we have 2 of them. So our budget is just 2 times 5 makes 10. Let's check our spending. And how did we do? 2, 4, 6, 8, 10, 12, 14. We've overspent by quite a bit. So in order to reduce the number of electrons in the structure, remember we had erase lone pairs on adjacent atoms and replace them with an additional bond. Let's check how we're doing now. 2, 4, 6, 8, 10, 12. We've still overspent. So we'll do the same thing. We can even do it again, removing a lone pair from two adjacent atoms and adding an additional bond. And indeed, triple bonds can exist. Single, double, and triple bonds are all found in these Lewis structures. And so now let's check one more time. 2, 4, 6, 8, 10. And there we are. Perfect. That is the Lewis structure for molecular nitrogen. On to the next example, number 4. So this one's a little bit special. You'll see why momentarily. So we have XeF4. Xe is a noble gas, xenon, and then F is fluorine. So xenon, when we're choosing the central atom here, we want to choose the least electronegative atom to be the central atom. And when we write out that mnemonic, Fonkelbrish, which is the most electronegative atoms on the periodic table, xenon isn't even on the list. It's less electronegative than any of these. So that's what's going to be at the center. So we'll do xenon in the center. And we have 4 fluorine atoms, which will connect to the xenon with single bonds. Okay. Everything needs an octet. Xenon already has one. But these fluorines all need 3 lone pairs to get an octet. Right? Because now each of the fluorines has 8 total electrons around it. 2, 4, 6, 8. And that's true for all of them. And the xenon now has an octet. So let's check what our budget is. Our electron budget. So to do that, we check the periodic table. We can do xenon first. Xenon's a noble gas. And like all noble gases, xenon will have... Oh, and I should mention, when you're counting the number of valence electrons, you can skip these transition metals. So when you're counting, you'll skip those. So for xenon, we have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. And indeed, all of the noble gases have 8 valence electrons. So xenon had 8, just one xenon, plus we have 4 fluorines, so 4 times, and fluorine's a halogen, and all of the halogens have, these are halogens, all of the halogens have 1, 2, 3, 4, 5, 6, 7 valence electrons. So 7. So that's 28 plus 8, which is 36. So our budget of electrons is 36. Let's check how we did. So lots of lone pairs to count up here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So we spent 32, but our budget is 36. We've underspent this time. We've only spent 32, so we need to add more electrons. And when you're in this situation, what you can do is you can add additional lone pairs to the central atom. And because xenon is in one of these lower rows of the periodic table, anything in the third row or below can have what's called an expanded octet. It can have even more than 8 electrons surrounding it. So we can add additional lone pairs. Now remember, we spent 32, but we wanted to spend 36. So we'll add 4 additional electrons, which would be 2 lone pairs. And that will get us to our budget. And I don't think we need to recount. You'll trust me on that one. We were at 32, we added 4, so now we're at 36. And this is the correct Lewis structure for this xenon tetrafluoride. All right. Last one here, BCl3. Whenever you see boron come up, you want to be, or you want to just remember that boron doesn't necessarily need a complete octet. It can have less than 8 electrons surrounding it. So when we make the Lewis structure for boron trichloride, well, first let's decide what element goes in the center, right? We'll choose the least electronegative. We always remember our little mnemonic, von Kolbrich. And here we see chlorine, pretty electronegative. Boron, on the other hand, isn't even on the list, right? This is bromine, not boron. Boron's less electronegative than any of these. So as the least electronegative atom, we'll put the boron in the center. And we'll draw single bonds connecting it to the other atoms, Cl, Cl, Cl. We'll give everything an octet. Well, at least we'll give the chlorines an octet. But remember, bromine is that special exception which doesn't need a full octet. So let's hold off on giving boron an octet for now and just find out what our budget is and see if we need to do anything more. Budget. So let's see. We need to do the boron. So let's find out how many valence electrons boron has. 1, 2, 3 valence electrons for boron. And then we have 3 chlorines. So chlorine is another halogen. And if you remember fluorine, chlorine also has 1, 2, 3, 4, 5, 6, 7 electrons, just like fluorine did. So this comes out to 24. Let's check and see how we did. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Perfect, just like our budget said it should be. We got 24. So that is the correct Lewis structure. And so that's it. Oh, by the way, if you're looking for how to do Lewis structures taking formal charge into account, or Lewis structures that include resonance structures, I'll do those in a subsequent video, but for now, this should have you covered on the majority of Lewis structures you need to do. So with that, thank you for watching. Hope this was helpful. Check out my other videos and take care.